Okay, this is day 13 of Unit 4. We started today with a homework quiz, so if you missed class, please make that up when you return. But we then did this warm-up, so you should pause the video, try it, and then play to check your answers. So the first one is 4 terms, so I'm going to try to factor by grouping. And let's try that again. So I'm going to group the first two. I see x cubed is the GCF. I'm left with x squared minus 25. So I copy the x squared minus 25, and that means I need a -1. So then I have a GCF between these two terms of x squared minus 25, and after that I have x cubed minus 1 is what I'm left with. So both of those factor further. We have difference of squares and difference of cubes, and that is my final answer. The other one, we're going to take this fraction and we're going to multiply by its complex conjugate, the denominator's complex conjugate, so times 5 minus I over 5 minus I. So first outer inner last, so 4 times 5, 20. 4 times -I, -4I. Inner 5 times -2I, -10I. And last, -2I times -I is +2I squared. So then the denominator, just first times first, 25. And last times last, I times -I is -I squared. So in the numerator, I can combine the -4I and the -10I to get -14I, and also 2 times -1, 2 times I squared, is going to be -2. And 25 plus or minus I squared, -I squared means -1 times -1, which is +1. So 25 plus 1 is 26. So 20 minus 2 is 18 minus 14I all over 26. And then I'm going to simplify that by breaking it into 2 separate fractions. 18/26 minus 14/26 I. And I can simplify that just a little bit further. 18/26 simplifies to 9/13 minus, and 14/26 simplifies to 7/13 I, and that is my final answer. Okay, so today we continued on in our notes with graphing quadratics. So we're going to graph these the same way we did yesterday, finding the x-intercept, y-intercept, and vertex. So I'm going to start this one by finding the vertex. So if I want to find the vertex, I have to first get this equation in standard form. So squaring 3x plus 1 gives me 9x squared plus 6x plus 1. Make sure you square that correctly. It's not just 9x squared plus 1. You need to remember the outer and the inner terms. And if you think it will help you, write the 3x plus 1 twice, and then first, outer, inner, last, or make a generic rectangle. Should give you 9x squared plus 6x plus 1. So now that we have it in standard form, we need it in vertex form, which means we need to complete the square. So I'm taking 9 out, and I'm leaving the plus 1 on the end. So if I factor a 9 out of positive 6x, I know that's going to be 9, I know that's going to be 6/9 x, 6/9. What we want is in the numerator, and what we factored out is in the denominator. So 6/9 times 9 would be 6. That looks good. Now 6/9, though, I know can be simplified. So I'm going to go ahead and simplify that. That's going to be 2/3. So 2/3 x. So if I have 2/3 x and I have a 1x squared now I'm ready to complete the square. I'll just put that up here. 2/3 is going to be multiplied by 1/2 or divided by 2. And I'm going to simplify on the diagonal first. So the 2's factor out. So now I can multiply 1/3. So 1/3 we know is being squared, which gives me 1/9. So 1/9 is what I'm going to add on. But it's actually 1/9 times 9, which is 1. So 1 was randomly added, which means 1 is subtracted. So I have y equals 9 is in the front. I have x quantity squared, and I know it's going to be what I had before squaring, which is plus 1/3. And then 1 minus 1 is 0. So now I have vertex form. So if I have vertex form, I have the vertex, which is negative 1/3, 0. So that's the vertex that I'm going to go ahead and plot. So negative 1/3, 0, right about there. So now I'm ready to get the intercepts. Now, hopefully you realized when we found that vertex, negative 1/3, 0, well, that also has, I just placed that vertex on the x-axis, which means that's not only the vertex, but it's also the x-intercept. So I don't really need to show any work for the x-intercept because I already found it. So just draw yourself an arrow. Okay, it's not only the vertex, but it's also the x-intercept. Now the y-intercept I do have to find. So I'm going to substitute a 0 in for x. I'm just going to put it in the original equation. So that gives me 3 times 0 is 0 plus 1. 1 squared is 1. So a 0, 1 is our y-intercept. So 0, 1 is right there. Okay, so I found the x-intercept, which is also the vertex, and I found the y-intercept. I only have 2 points, but I do have, well, one of those 2 points is the vertex. So because I know the vertex, I can find the distance between the y-intercept and the vertex and then get the mirror image on the other side. So I see that that's 1/3 the distance from the y-intercept to the vertex. So I'm going to go 1/3 in the opposite direction, which is going to take me about there to negative 2/3, 1. That point, negative 2/3, comma 1. And that's going to be the mirror image. So now I have my 3 points that I can graph the parabola, label the vertex, negative 1/3, 0, and the y-intercept is 0, 1, and there's a good graph. Now, you should always also double check that your graph matches your work, your math. And when we got this equation into vertex form, we now know the a value is 9. Remember from earlier in the unit, we know that 9 for an a value means a vertical stretch. Not only is it a vertical stretch, but 9's a pretty big number compared to like a stretch of 2 or 3 or 4. 9's pretty big stretch, meaning that the parabola is really going to be stretched. And if I check that, it is a positive orientation parabola, and it is very skinny because it has been stretched vertically a lot, significantly. So my graph does match my work. It does match my equation. Okay, now if I had over here negative 1/9, then, and I looked at my graph, I know I did something wrong. Either the math's wrong or the graph's wrong. But positive 9 does match as an a value with my graph. Okay, moving right along to our next example. This one is actually in your packet. You can find it on page 25. It's problem number 7. So let's go ahead and try that one. We're going to do the same thing. We're going to find the vertex, the x and y intercepts. So I'm going to go ahead and multiply this out to get it in standard form. Now remember, with multiplication, I could do 2 times the quantity x minus 1 first, and then take that times the quantity x plus 1, or I could do x minus 1 times the quantity x plus 1. And order doesn't matter with multiplication, but be smart about it. We already know the product of the quantity x minus 1 times the quantity x plus 1, so why don't we multiply them first? So we know that's difference of squares, which means it's x squared minus 1. So then I'm going to multiply that times 2, distributing the 2 gives me 2x squared minus 2. Now I have it in standard form. I'm going to get it in vertex form. So I'm going to factor the 2 out. I'm left with x squared. I'm going to bring that negative 2 outside. Looking at the original equation, in standard form, I have 0x. So then I'm taking half of 0, which is 0. I'm squaring that, which is 0. So it's kind of strange to write this, and you don't actually have to, but we'll just go through the process we normally do. 2 times 0 is 0, so I randomly added on 0, which means I'll subtract 0. Okay, and then I can rewrite this in vertex form. So I have 2 parentheses x plus 0, the quantity squared, and then minus 2. Now, you might be saying, well, okay, well, 2 times the quantity x plus 0 squared is the same thing as 2x squared. Yes, I agree. However, this form here is standard form, and this is vertex form. Okay, so if the goal is to put it in vertex form, which it is, this is how you want to write it, not 2x squared. So you do want 2 parentheses x plus 0 squared, which then tells us that our vertex is at 0, negative 2. So let's go to 0, negative 2 and plot that point. Okay. Now you might be noticing that not only did we just plot the vertex, but we plotted it on the y-axis, which means we just found the y-intercept. So because we already found it, we can just say, yep, there's our work. It was not only the vertex, but it was also the y-intercept. So now all I need is to find the x-intercept. So I'm going to substitute 0 in for y. Now I have my pick here. I could substitute it into vertex form, or standard form, or factored form. Well, clearly the easiest choice, since it's going to be set equal to 0, the easiest choice would be factored form, because I don't have to do any work. It's already been factored for me. The other two, I'd have to do some work in order to solve for x. So I know that using the zero product property, x minus 1 equals 0, which means x equals 1, or x plus 1 equals 0, which means x equals negative 1. So as coordinate points, 1, 0, and negative 1, 0 are my x-intercepts. So let me plot those. 1, 0 right there, negative 1, 0 there. Okay, I have my x-intercepts, my y-intercept, which is my vertex. I do have 3 points. 3 points are enough to graph the parabola. Labeling the vertex, which is the y-intercept, and the x-intercepts. And we are done. Okay, once again, check to make sure your math matches. In vertex form, I have a value of 2. This does have a positive orientation, and it does appear a little bit stretched. Not real skinny, because it's only at 2, but it does appear to be stretched. A little bit skinnier than the normal quadratic equation. So that takes care of that example. That's it for our notes for today. Your homework is pages 24 and 25 in your Unit 4 packet. Reminder, you have a team test coming up on Thursday next week, and then the following week before Thanksgiving break, we'll have a 2-day test on Monday and Tuesday. So work on 24 and 25 for Monday.